a lot of them. And then every once in a while you'll hit. Okay, so let's jump into example 12, finishing up 9.4. So 9.12, or I'm sorry, example 12. Golly, off to a great start. And I'm only recording in y'all's class because I messed up last period. Yeah, I think my tie is on too tight is what's really happening. So I thought I would have the bright idea of writing a question similar to a previous AP question, but I did not work out all the kinks in advance, and so some of the numbers are going to be a little bit cumbersome and tedious, but that's okay. We'll work through it together. We got a lot of collective brain power in this room. Yeah? Yeah, okay, good. So this is similar to the BC 6 question number 6 on the 2008 exam, Form B, which was the Pacific Islander exam. Very, very similar to it. It's a no calculator question. No calculator question. So here's kind of what College Board might ask you. All right, so let f be the function given by that. F of x equals 1 over 1 plus x squared. The domain looks like it's what? What's the domain? Well, the function. All real numbers, right? 1 plus x squared is number 0, so the domain is all real numbers. Cool. All right. Part A, write the first 4 non-zero terms and the general term for the Taylor series centered at 0, also called a what series? Maclaurin. Yeah. All right. So you have 2 options here, really 3. You can use Taylor's theorem to take derivatives and evaluate it at 0 to generate the numerators of your coefficients. You could use long division here if you want to, or you can modify a geometric series, right? It looks very, very close to 1 over 1 minus x. So that's, I think, what I'm going to do. That's the route I'm going to take. So 1 over 1 plus x squared, if I write it in that format, is 1 over 1 minus what? Negative x squared. Okay, good. So this is going to be what I'm eventually calling my r. The absolute value of r is equal to the absolute value of negative x squared. Okay? So I can modify an existing geometric series. So let's go ahead and write out our geometric series. 1 over 1 minus x. It's 1 plus x squared plus x cubed. There's the first 4 non-zero terms. Plus yada, yada, yada. Plus x to the n plus yada, yada, yada. So make sure that it's pretty, right? 3 ellipsis points is all you need. That's not good. 3. Did you put 2? No, because 2 is just yada, yada. And they're like, what comes next? So it's really like a sequence. Really? And 3 is the minimum number of terms. You could put 4, Katie, but I would not put 2. Did you put 2? No. Okay, you were just asking a hypothetical question, being the advocate for the devil. All right. So now we're going to replace x with negative x squared. So I can go right to the 1 over 1 plus x squared. And I've already got my substitution highlighted up there. So it's going to be 1, then it becomes minus x squared. And the next one, when I square it, it becomes positive, and I get x to the 4th. When I cube it, it stays negative, bless you, and I get x squared cubed, which is x to the 6th. So if you notice, it's turned itself into an alternating series. And then plus yada, 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 psych, plus, and again, we could do this. We could just say it's negative x squared quantity to the nth power. That's not so bad, right? But remember, what we want to do is try to separate things. So off to the side, let's go ahead and think about it. Negative x squared to the nth power is the same as negative 1 to the n times x to the 2 to the nth, which would be to the 2 times n. And so that is a much, way to go. Way to go, Tate. There's hope for you yet. Yeah, he doesn't like math. Okay. All right, so negative 1 to the nth times x to the 2 to the nth. So that's a preferred nth term. Okay, so did I answer the question? Are we done? First 4 non-zero terms, 1, 2, 3, 4, good. And I got the general term. That's it. Do we have to write it in the condensed sigma form right here? No, we don't. Okay, so that should be worth probably 3 points. The way they're going to grade that is you're going to get 1 check for the first 2 terms. Then you're going to get a second check for the second 2 terms. And then guess where the third check comes from? Yeah, the general term or the nth term. And if you have anything misstated or incorrect, you're going to lose one of the checks. For instance, if you have a squiggles here instead of an equal sign. Why is this an equal, not a squiggles? It's a series, right? Not a Taylor polynomial. It's a series. So you'd lose a check if you have a series. If you have dot dot instead of dot dot dot. Yeah. Okay. All right. Moving right along then. Part B. Does the series found in Part A, when evaluated at 1, converge to f of 1? Explain why or why not. So what we're really asking is x equals 1 in the domain? Is x equals 1 in the domain / interval of convergence? You don't have to write this down. I'm just writing it down for instructional purposes. Is x equals 1 in the domain or the interval of convergence of the series? All right, so you don't really need to state that it's a geometric series here because they're asking you about a specific number instead of an entire interval. But you could use that as your justification. All right, so we'll do this a couple of ways. Number one, you could say 1 over 1 plus x squared is a geometric series, as we just shown up above, with the absolute value of r, the ratio, being the absolute value of negative x squared, which is equal to the absolute value of x squared. Yes. Yes. Very, very well. Yeah, the final countdown got her pumped up.
Okay. That's perfect. On the quiz, did you give them credit for any two angles adding anything they possibly did it?
Only if they simplified. They had to add up to the right angle, and they had to simplify down. So, like if it was 17 and they used 1 and 16, I didn't give them credit. But as long as they were two angles that added up to the right number or subtracted, and yeah, and I trusted them to do the arithmetic. I did. Yeah. 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 Okay. So the absolute value of x squared, because the negative goes away, has to be less than 1. And we've seen this before. If a number squared is going to be less than 1, then that number has to be less than 1. And since our center was 0, we get it into the format we want. X minus our center, x minus the center, is less than the radius. Okay? And because we said it was geometric, we know then that the series only converges where? If you drew your little number line, there's 0. You go one to the right to 1. You go 1 to the left to -1. We know it only converges on the interval from -1 to 1. Because it's a geometric series, we say that right up here, we don't have to test the endpoints. And now you could say, now you can answer the question. So, no, the series does not converge to f of 1 because it's not in the interval that I stated above. That's one way to do it. Okay, what's another way to do it? Since they're just asking you about one value, you can actually test it out. You can actually plug it in for x and see if it converges. Now, to do that, you're going to need the condensed version up here, the sigma notation. So let's come up here and write it. This is also equal to sigma from n equals something to infinity of -1 to the n times x to the 2n. And remember, the starting value is important. In order to get a first value of +1, our x has to start with what? 0. And when I do that, -1 to the 0 is a positive number, so the alternator works out. So there is another version of it. Now, I probably wouldn't volunteer that up there, because now you just have the burden of being correct. But of course, if you know it's right, go for it. But instead, I'm going to pull that down here, paste it, and now I can say, okay, I'm going to test x equals 1. I'm just going to plug it in. This would be equivalent to testing endpoints. But you could do this without even saying it's geometric. It says, does it converge? Well, let's see. Let's plug it in. When I plug it in, I get 0 to infinity, -1 to the n, 1 to the 2n. Well, what's 1 to any power? It's 1, right? That's truly something that is 1, not something that approaches 1. It's 1, so I just end up with -1 to the n, which if you expand it is +1 minus 1 plus 1 minus 1. So this what? It diverges. Yeah, by what? By the nth term test. Yeah, it diverges by the nth term test. And now you could say, so no, the series, and I'm using their words here, the series does not converge to f of 1. Yeah. Oh, I'm saying the series only converges on the open interval from -1 to 1. That's what I'm saying, yeah. Because it's a geometric series, that series only converges from -1 to 1 open. And since I can't include the right endpoint now, which is 1, the series does not converge to f of 1. So yeah, I'm saying the series only converges here, and x equals 1 is not included, so it doesn't converge there. Yeah, I'm sorry for the confusion. But yeah, either one of those arguments would work, all right? Now, if it asks you if it converged at 0.5, you could do the same thing. You could say the series converges on the open interval from -1 to 1, and 0.5 is in that interval, so yes. Or you could plug in a 0.5 for x and show that it's going to be a geometric series that alternates, that converges. All right, so whatever you prefer. Now, for all that work, guess how many points you're going to get? 1 point for that. The answer with the explanation. Okay, well, we'll take it. You don't know where the points are coming from as you work the problem. You're just getting all of them, right? It's 9 at the end, so you can say, all right, give them to me whenever you want. So we've got 4 points so far. Yeah? All right, part C. The derivative of arctangent is 1 over 1 plus x squared. Oh, yeah, it is, right? Man, that question came up on one of the multiple choice sections, and I forgot what it was. They told me what the answer is now. Can I go back to the multiple choice and answer it correctly now? No, it's a closed off section. So anyway, you knew that. Arctangent's derivative is 1 over 1 plus x squared. So this is them giving you a little hint. Write the first 4 non-zero terms of the Taylor series for arctangent of x centered around 0. Okay, if I'm trying to write it for arctangent of x, I need to be able to use what I have up here. So I'm going to rewrite this, or in this case, I'm going to copy it, and I'm going to paste it. So remember that I can modify a series, and it doesn't change the radius of convergence if I integrate it or differentiate it. But I will install it later. Remind me later. Okay, but I must recheck the endpoints if I want to know the new interval of convergence. Okay, but it's not going to ask me for the interval of convergence here, so I'm okay. All right, so to get arctangent then from 1 over 1 plus x squared, I have to do what? I have to integrate. Good. So here's what we would show then. We would show then that the integral, the integral of 1 over 1 plus x squared dx is equal to, it's equal to arctangent of x plus c. You can actually throw that in there right now if you want, arctangent of x plus c, right? That right there could be its own question. That's pretty easy. Now what we're going to do is actually integrate the right-hand side. And when we do integrate, we can either put the plus c at the very, very end, or because we write things in increasing order, it would be better to put it where? In the beginning. So as long as you don't forget it, I'll put it in the beginning, plus. And now all we're going to do is go through and integrate each of these terms. So 1 becomes x. Negative x squared becomes 1/3 x cubed, or just minus x cubed over 3. X to the 4th becomes positive x to the 5th over 5. Minus x to the 6th becomes x to the 7th over 7, plus ... And now we can do the same thing to the nth term, plus negative 1 times x to the 2n plus 1 all over 2n plus 1 plus ... Sweet. Oh, I forgot the n. Yep, sweet. Good catch, good eye. All right, so what happens with our plus c's? They cancel. Yeah. Now, if you ever needed an initial condition to find it, you can actually create a point if you needed to. Because we know it converges at the center, we know that they have the exact same value. So you can actually just plug it in. What is arctangent of 0? What is arctangent of 0? It's 0. Right. So if you needed an initial condition, you could use the point 0, 0 to find c. Just remember that every series and the function it's representing will always converge at the center. So you can always use the center as an ordered pair. All right. Now, in fact, here's another way to do it. If you didn't even want to bother with the c's, you could actually integrate from 0, which is the center, to any allowable value of x, of 1 over 1 plus, we would call that t squared dt. And then if you evaluate that, it's going to be the same thing. You're going to plug in the x when you're done, and then minus when you plug in the 0, everything will cancel out. So you can do it that way. I like doing it this way, just putting your plus c's and letting your plus c's cancel. Okay, so do I have it, first 4 non-zero terms? Should I leave it in this format? That's a good question. It asked me for arctangent series. I have that kind of plus c in the way, don't I? It's canceled out, so it kind of looks a little gross. So I would probably take one more line. So arctangent of x is equal to x minus x cubed third, and this would be your chance to like pretty it up, or in my case, write it actually in worse style, x to the 7th over 7 plus dot 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 negative 1dn. Yeah, make sure you always kind of answer the question. Make sure you're presenting it on a silver platter. You don't need to box it. Remember, your last line is considered your answer. So if I stop right here, how am I doing? I've got 4 terms, 1, 2, 3, 4, plus my general term, which is good. Very good. This is where you don't want to stop. You got to have plus dot 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 at the end. So little details like that. All right, so now I've definitively answered it. We know for sure that this would still converge on the open interval from -1 to 1. For sure, for sure, for sure. If we wanted to know if it worked at 1, we would just plug it back in and retest the endpoints, right? When you differentiate or integrate, you don't change the radius. You only possible change the endpoints. Okay. So I think that's going to be worth, how many points are left? 3, 4, 5, 6, 7. I think this is worth 2 points. Yeah, 2 points. Check, check. You're going to get, I think you're going to get 1 for the terms. We'll check here in a little bit, and then 1 for the nth term, I believe. All right, so in this case, the last part was worth 3 points. The last part, when it deals with error, a lot of times is only worth a single point. But in this case, they assigned it to 3 points. Now let's read about it. This is a segue into the next section. Use the series found above in part C to find a rational number, so it's not irrational, A, such that the absolute value of the difference between A and arctangent of 3/4 is less than 1/10. Justify your answer. Okay? So what do we call this? If we take some value and we subtract it from arctangent of 3/4, which would be the actual value of arctangent at 3/4, it's the error. Yeah, so this has a very distinctive look. This is the approximate. We're going to let A be the approximate value of arctangent of 3/4, which we're going to find. And of course, this would be the actual. So anytime you have the approximate minus the actual and you take its absolute value, you get what we call the error, or also called the remainder. Same thing. And what we want to do is we want to find an approximation so that the error is bounded by 1/10. This would be what we're calling our error bound here. We want it to be within 1/10 of the actual number. So the last section, which we're starting tomorrow, Lagrange error bound, deals with this idea for any polynomial approximation. We don't know Lagrange error bound yet because we don't need it, because this particular series is a special type of series, which is what? Well, it's a Maclaurin series, but it's also an alternating series. And if you remember, we talked about 2 error bounds for the series, the integral test and the alternating series test. The integral test error bound is not on the AP exam, but let's review what that was. If you wanted to get an approximation, you could add up the first 5 terms, and then the error bound is going to be the integral from 5 to infinity. Okay, you'll know that the sum is going to be within that. But for the alternating series, it was actually a little bit easier. If you added up the first 5 terms to get an approximation of the sum, that is going to be within the absolute value of the 6th term. Remember, it's the first unused term is going to be your error bound. If you add up the first 10 terms, that sum is going to be within the absolute value of the 11th term from the actual. So here's what I'm going to do. I'm going to go ahead and say then that arctangent of 3/4, basically all I'm doing is I'm letting x equals 3/4. That's what they gave me. If I start plugging it in right there, let's see what I get. It's going to equal 3/4 minus 3/4 cubed over 3 plus 3/4 to the 5th over 5 minus 3/4 to the 7 over 7 plus yada, 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 right? I'm not going to even write the nth term, but would you agree? That's the whole purpose of this series. 3/4, by the way, is between -1 and 1, yes? So 3/4 is easily on the open interval. So for infinitely many terms, the polynomial on the right is going to be an exact value for arctangent of 3/4. The problem is we can't go out infinitely many terms, can we? So here's what we want to do. We want to know how many terms do I need to add up so that when I stop, I get an approximation value A that's going to be within 1/10 of the actual sum. So that's the same thing as asking, because it's alternating series, which of those terms is going to be the first term that is smaller than 1/10. And this is without a calculator. So let's just try it out. This would be the first term. We'll call that A sub 1. A sub 1 is equal to 3/4. Is that less than 1/10? No. All right, cool. So let's move on to the next term. And we're doing the absolute value, so I'll do the absolute value. There we go. The second term is 3/4 cubed. So that's going to be 3 cubed over 4 cubed, and then another 3 in the bottom. That's how you would simplify that? 3 cubed over 4 cubed. Well, that's going to be, let's see, 3 cubed is 27. 27 divided by 3 is 9. And then 4 cubed is 16 times 4, which is 64. Is 64 less than 1/10? I mean, 9/64. I don't think so, right? If you multiply the 1/10 by 9 over 9, you get 9/90ths, and 9/90ths is actually smaller than 9/64. All right, so that's not gonna be it. So I'll just put a same thing here. I'm going to put not, and now I move on to the next term. Hey, Scooby Dooby Doo. That scared the heck out of me. Okay, 3 to the 5th over 4 to the 5th times 5. All right. Now here's where I failed in writing this question. I made the numbers kind of ugly. This is all without a calculator. So 3 to the 5th, let's figure out what that is. 3 to the 4th is 81. 81 times 3 is 243. All over 4 to the 5th, let's see, 4 to the 3rd is 64. So 64 times 4 is going to be 256. That's going to be 4 to the 4th. And then times another 4. That's going to be, we're doing old school math here, right? That's going to be 22, so that's 1,024. So that's 4 to the 5th. And now times 5, multiply that by 5. Yeah, this reminds me of like Sealy Mathletics. Remember that? Go on the dry erase boards. Some of y'all participated in that. That was the last year we did it. So you get 5120? Yeah. So this is 243 over 5120. The question is that less than 1/10? Well, let's see. If I get a common denominator, that's pretty easy. I can just multiply this by 512 over 512. Which means, is that less than 512 over 5120? Yes, it is, okay? So here's, and the numbers aren't incredibly bad, but it's a little bit arduous. So here's another thing to remember. If you're doing this without a calculator, they're not going to make you go out to like the 7th term or the 8th term. It's going to be, maybe you go out to the 3rd term, maybe to the 4th. But anyway, we found it. We found the first term that is actually less than 1/10, okay? And so what does that mean? That means the 3rd term is going to be the first unused term. And then that means I add up all the other ones. Now I have to say why. It says justification. So we could say A, first of all, is going to be the sum of the first 2 terms, which is 3/4 minus, and we've already calculated the second term is 3/4 cubed over 3. It ended up being 9/64 minus 9/64. Do we have to simplify that? No, we don't have to. So A is going to equal that, since the series is an alternating series. An alternating series. What are the two things that are required for the alternating series to apply besides it being an alternator? What do the terms have to do? Two things. They have to decrease and go to 0. Yeah, so let's say that. Since the series is an alternating series with decreasing terms approaching zeros, or with terms that decrease to 0. That's an easy way to say it. With terms that decrease to 0. Ooh. Okay? And so, we know that the error, A minus the arctangent of 3/4, is going to be less than the absolute value of A sub 3, which equals, and we just show that work over here, 2143 over 5120, which is less than 1/10. Okay? Oops. Thank you. Yeah. So when it says to show that, this is like where you actually do want to kind of work out the numbers instead of just taking it on faith. All right? So there you go. That should work. We found the A value. It's the sum of the first two terms because the third term's absolute value was the first term that was less than the error bound that they gave me. Right? Does that make sense? And so to justify, we have to say it's an alternating series with terms that decrease to 0, and then we go ahead and answer the question. All right? All right, and that's going to be worth 3 points. Here's where the 3 points come from. You're going to get 1 point just for plugging in a 3/4 for x, just for using x equals 3/4. That's a check. The second check is going to come from coming up with the sum of the first two terms, and then all of this right here, the justification, is the third check. So remember, there's only 2 tests of all of the 8 that we learned, or 9 really if you include the root test, where you have to know the qualifying conditions. The alternating series, the terms have to decrease to 0, and the integral test, remember, is dogs have to cuss in prison. It has to be decreasing, continuous, and positive. That's it, okay? So we'll stop right there. After lunch, we're going to do the last one, example 13, all right? Have a great lunch.